Alright guys, I have math homework, page 729 and 730 to do, but I'm going to finish up these two hot problems. You know, I really do love these hot problems. So we have to figure out which one doesn't belong. Circle the expression that does not belong with the other three. Explain. Right, these are all expressions because there's no equal sign and an answer or a known. So 1/2 times 12, right, would be the same as 1/2 times 12 over 1, which would be 12, right, because 1 times 2 is 12. Sorry, 1 times 12 is 12, over 2 times 1 is 2. I'm going to divide the top and the bottom by 2. So 12 divided by 2 is 6. 2 divided by 2 is 1, and 6 over 1 is 6. All right, I'm going to do the next problem. 9 times 2/3. So I'm going to say this is going to be the same as 9 over 1 times 2 over 3, 2/3. 9 times 2 is 18, and 1 times 3 is 3. And I'm going to divide the top and the bottom by 3 this time, since they're both divisible by 3. 3 divided by 3 is 1. 18 divided by 3 is 6, right? 6 times 3 is 18. Final answer is 6. So these are the same answer, right? How about this one? Let's say 1/4 times 20 over 1, right? This is one of those problems where I can see that, oh, it's going to be 5 because 5 times 4 is 20. But okay, we'll keep going. 20 over 4. I'm going to divide by 4, divide by 4. Whatever I do to the bottom, I have to do the top. 4 divided by 4 is 1. 20 divided by 4 is 5. My answer is 5. Oop, right? I have an answer of 6, an answer of 6, an answer of 5. Sorry, that's why I should have explained that. That's why when I was looking at these problems, I thought, oh, this one looks like a 6, this one does not look like a 6, but this one, so that's why my first way to solve this problem was thinking I'm going to solve for them and see, I bet you this answer, something will be, maybe these will be multiples of 6, but they are just 6. All right, so now this last one, I'm going to do 1, right? And I can see this, 1, 6. I know 6 times 6 is 36. I'm going to say my answer is 6, but I'm going to do my math. Over 1, right? I'm turning 36 into a fraction. Just put it over a 1. Now it's a fraction. Now I'm going to multiply my numerators. 1 times 36. My denominators, 6 times 1. I'm going to divide both the top and the bottom by the same number, which is going to be 6. And 6 divided by 6 is 1. 36 divided by 6 is 6. My final answer is 6. I'm going to circle this one, and I'm going to say the products, right? A product is the answer to a multiplication problem, right? I take one factor times another factor, and I get a product. It's a multiplication problem. So the products of the other 3 problems is 6. I'm going to say, and then I'll do this here. I'm going to explain a little bit more. I'll put a semicolon in because these are like 2 parts of my answer. 1/4 times 20 equals, I'm going to put my 5. And that's my explaining part. I explained down here. All right, last hot problem. Building an essential question. Can all whole numbers be written as fractions? Explain. I'm going to say yes, comma. So this is another reason I use a comma. After I say yes, and then I'm going to tell why my yes. If I'd answer and say, yes, I like ice cream, I wouldn't do it. But here I'm going to say yes. I'm going to pause and tell them why my yes. And I'm going to use my word because. Right, this is a math problem, so I don't need to make a complete sentence, but I'm going to just for fun and practicing. Yes, because any whole number can be written with 1 as the number on the bottom of a fraction is called the denominator. And I'll give them an example. 26 equals 26 over 1. All right, on to the homework. So they gave me a problem, right? They always give me a sample problem to show me what I'm going to be doing. So here's my word problem up here. And remember, we are multiplying whole numbers and fractions. So Leon was given 10 days to finish his art project. He used 2/3 of his time to paint the project. For how many days did Leon paint his project? Right, so out of the 10 days, 2/3 of those days were used just for painting. So I can figure that out by taking 2/3 times 10. They're going to do a little sample here, right? They're just doing a little estimating. Well, I know 2/3. I could multiply it times 9 here, and I would get 6. Right? I was kind of, but I'm not doing that yet. So I could show you. This would be just a little bit of an easier problem than times 10 because I know I can reduce here. Right? Otherwise, I'd have 30 over 3. Sorry, I'd have 20 over 3. And I can't divide 20 by 3. But if I could do 2 times 9, I'd have 18 over 3, and I can divide 18 by 3. I'm going to divide the top and the bottom by 3, and then I'll have 18 divided by 3 is 6. We just did that. 3 divided by 3 is 1, and my final answer would be 6. That's going to be my estimate. So when I get to my end, I'll see, is my estimate close to my actual answer? Just to make sure I was doing it right. So I'm going to do the real problem now, 2/3 times 10. So I put my 10 over my 1, and now I'll have 2 times 10 and 3 times 1, which would be 20 over 3, right? This isn't reducible evenly. I'd have to have a fraction. I'd have 20 over 3 is the same as 20 divided by 3, which equals, I'll do my math, 20 divided by 3, right? 3 cannot go into 2, but 3 can go into 20. I know 3 sixes is 18, or 6 threes is 18. So 6 times 3 is going to be 18. I will subtract, right? You can't subtract from that 0. You'll borrow here from the 1, turn it into a 10, 10, take away 8. I can do. I'll have a 2. My 2 is my new numerator, and I still have the same denominator I always had. My answer is 6 and 2/3, which would round up to 7, right? 2/3 is closer to 7 than it is to 6, or to 0. Sorry, 2/3 is closer to 1 than it is to 0. 1/3 would be closer to 0. 2/3 is closer to 1. All right, so I would have 7, but this is close enough. 6 is about 6 and 2/3. All right, so now we're going to go do the problems down here. So 2/3 times 12. So I'm going to say 2/3 times 12 over 1 equals 12 times 2. Right, there's 24 hours in the day. My clock has a 12 on it. 2 times around the clock gives me 24 hours. 3 times 1 is 3. 24 over 3. I'm going to divide my top and my bottom by 3 since both numbers are divisible by 3. Like 24 divided by 3 is 8. 8 times 3 is 24. 3 divided by 3 is 1. My final answer is 8. All right, I'm going to go to the next problem. If you need to pause it, just pause it. Pause the video. So I'm going to turn this problem into 8 over 1 times 1 over 5. So now I'm going to have 8 times 1 is 8. 1 times 5 is 5. I have an improper fraction, so I will fix that. I'm going to fix it this way. I'm going to add two numbers together. They're both going to have a denominator of 5, right? 5, 5, 5. And I'm going to turn this one into 5 5s. So I have a 1. And then 5 plus 3 would have given me my 8. So my final answer is going to be 1 and 3/5 plus 3/5, but I don't need to write my addition sign there. All right, 13 times 1/2, right? I can do this one in my head even, because I know 14 in half would be 7, right? This is a little bit more, so it's going to be 7.5. But let's do our math. 13 over 1 times 1/2 is going to be the same as 13 halves. Right, so I could do a bunch of different ways with it. But, or I could even do it this way. I'd have to have 2 over 2 plus 2 over 2 plus 2 over 2 plus 2 over 2 plus 1 over 2. So we won't do it that way. We'll do the 13 divided by 2 way. So 13 divided by 2 is, sorry, I have to, can 2 go into 1? No. Can 2 go into 12? So can 2 go into 13? Yes. It goes into 12 6 times, right? But 12 is less than 13, so that's a good number for me to use. I'll subtract. Sorry, I said 7.5 earlier, right? It's only 6.5 because I didn't go up to 14. Anyway, sorry. Okay, so that's why I double check my math. So 6 times 2 is 12. I subtract, I get 1. My final answer is 6.5. Right, I needed to look at this and think 12 and think 2 12s would be, 2 6s would be 12 plus that 1. I'm going to split it in half. I'd have 6.5 if I divide it into halves. All right, my next problem is 20 over 1 times 3 over 5. So 20 times 3, right, I'll take my 3 times my 2 and then put the 0 back. So I'm going to say is going to be 60 over 5. And I could do the same thing, right? I could say 5 over 5 plus 5 over 5 plus 5 and figure out how many ones I'd get. Or I could just do my division, 60 divided by 5. And does 5 go into 6? Yes. 1 time. 1 times 5 is 5. Subtract 1. Bring down my 0. Now I have 10. 2 times 5 is 10. I subtract, I get 0. My final answer is 12. All right, next problem. I'm going to say 3/10 times 7 is the same as 3 10s times 7 out of 1. 3 times 7 is 21. 10 times 1 is 10. Right, this one isn't going to take me too much. I know 10 plus 10 is going to give me my 20. So what if I add 3 numbers together? I'll need one more tenth, right? I'll have 10, 20 plus my 1 more, right? That gives me 21 tenths. So I know my answer is going to be 1, 2 plus my 1 tenth. On to the back. All right. The length of a popcorn machine is 3/4 of its height, right? I don't know how length is, but I know its height is 24 inches. It's 24 inches tall. So this is going to be shorter by, it's going to be 3/4 of it. So I'm going to multiply 24 times 3/4. So I'm going to do 24, right? This is how I've been doing on the computer. We do it this way because it's harder to put the number straight underneath it. 24, oops, times, right? I can make my times like this. I can make it a star. Same thing. This is an X or a star works. I could even make it a dot. That would work. So I'm going to say 24 over 1 times 3 over 4 equals, I'm going to do my numerators, 24 times 3 over 1 times 4. Oops, now I wrote it straight. I was trying to write them sideways, but it's harder, right? Because when I write 2 numbers, it's harder to write them sideways like that, but I just kind of forgot. All right, 24 times 3. My brain is old. 4 times 3 is 12. I'll carry my 1. 3 times 2 is 6 plus 1 is 72. So I'm going to have 72 over 4. Right, and we will not leave it like that. We'll take our 72 and divide it by 4. All right, so I could do 4 over 4 plus 4 over 4 plus 4 over 4. Or I'm going to do it this way. So 4 goes into 7 one time. 1 times 4 is 4. I write it under my number, right? I stay nice and lined up. I'm going to subtract. I'm going to have a 32. And hopefully you remember 8 times 4 is 32, right? If you don't, you can look at your chart and see it on your chart. Sorry, I thought I could grab my chart quicker than this. Right, I would go, is there any that are so, what's the closest number? Anyway, oh, it is 32, right? 4 times 8. So I'm going to say 8 times 4 is 32. Subtract 0, done. So my final is 8. My final answer is 8 inches, right? We're measuring in inches. So this is 24 inches, and this is only 8 inches wide. Sorry, 18. How did I forget my 1? Right, I needed 18 inches. This is, when I looked at it, I'm going, wait, 24 by, no, that's 2, wrong. Right, this is shorter by 3/4. This is 24 inches, and this is 18 inches. You can even label it right there. Label your diagram. All right, so your picture. All right, here's Quentin is making bread and wants to triple the recipe. The recipe calls for 2/3 cup of sugar. How much sugar will he need? So he needs, for one recipe, he needs 2/3 of a cup. And he's going to figure out how he's going to multiply that by 3, right? He could do 2/3 plus 2/3 plus 2/3. He could do it that way. Right? You could do it this way, especially with a small number like that. 3, 3, 3, 3. 2 plus 2 plus 2 is 6. I can divide the top and the bottom by 3. And I will get 6 divided by 3 is 2, 3 divided by 3 is 1, and my final answer is 2 cups of sugar. And I can abbreviate cups like that. I could have also done it this way, right? 2 times 2/3 times 3/1, which would be 6/3. And I divide, right? I could do it this way too. I'll say 6 divided by 3 goes 2 times. So my final answer is 2, right? 2 times 3 is 6. I would subtract, have 0, 2. I could do it 2 ways, right? Just so you guys can see, I got the same answer. So here is Joaquin. He has $24. He used 5/8 of his money to buy a pair of jeans. How much money did Joaquin spend on jeans? So I'm going to take his $24 and figure out how much 5/8 of that would be. Right, I could do 5/8 plus 5/8 plus 5/8 plus 5/8 24 times. But hopefully you see that's not a very efficient way to do this problem. So instead I'm just going to multiply it out. 24 times 24/1 times 5/8. So I need to do my 24 times 5. I'll do it right here. Figure out what that's going to be, right? That will be the numerator on my fraction. My denominator is just going to be 8. 1 times 8 is 8. All right, so 24 times 5. First I'll multiply the number in the ones place times the number in the ones place, right? 4 times 5 is 20. Carry my 2. 5 times 2 is 10, plus I have to add that 2 in there. 12. So my numerator is going to be 120. I have to figure out 120 divided by 8. Right, I could do 8 over 8 or 8 over 8, and I could keep doing it like that, but this is that's going to take me a while. So instead, I'm going to do my long division problem. Right, can 8 go into 1? No. Can 8 go into 12? Yes. One time. I'm going to write my number over the number I'm dividing by, right? 1 times 8, and write my number, my product under the number where I need to subtract it in the ones place here. So I'm going to say 2, take away 8, nope. But 12, I can take away 8, yep, I'll have 4, because there's no number here, right? So I'll have a 4. I'll bring down my next number, it's a 0. 8 times something is 40, right? Done. I did 5 times 8 is 40, subtracted, I got 0. My final answer is 15. But for Joaquin, this is $15 he spent on jeans. All right, write and solve a real-world problem involving the multiplication of a fraction and a whole number whose product is between 10 and 15. All right, so I'm going to try and use numbers that will work to have my answer, my product between 10 and 15, my answer to my problem.